All right, grab some paper, grab a pen or pencil, maybe a calculator, and let's go through the 2023 ICTM Regional A geometry problems. So question 1, the length of one side of an equilateral triangle is 8. So we want to determine the numeric area of this triangle. So 8, 8, and 8. So the area formula for a triangle is 1/2 the base times the height. And so what we need is the height. Now in an equilateral triangle, that breaks the bottom into 2 equal parts, 4 and 4. And this is 60, and this is 30. So it breaks it into a 30, 60, 90 right triangle. So that means the altitude is the longer leg of this 30, 60, 90 triangle. So this is 4 square root of 3. So the area is going to be 1/2 times the bottom base, which is 8, that's whole thing, times 4 square root of 3. So we have 1/2 times 8 is 4, times 4 is 16, square root of 3. And this question doesn't say anything about an approximation or a decimal, so we're going to leave it in this exact simplified form. Question 2. In this sketch, AB and CD are congruent. AC is equal to 3x minus 12, BC is 2x minus 5, and BD is 2x plus 5. All right, let's draw a slightly larger picture. We've got A, we've got B, we've got C, and we've got D. So they give us that AC is 3x minus 12, BC is 2x minus 5, and BD is equal to 2x plus 5. All right. Now, important thing is that AB and CD are congruent, so these two lengths are equal. Now, the other important thing is that BC is congruent to itself. So AB and BC together equals BC and CD together. So that means that we can set these two quantities equal to each other. Down here, we'll say 3x minus 12 equals 2x plus 5. So when I subtract 2x, we get x minus 12 equals 5. And then we add 12, so x equals 17. But that is not our answer because we want the length of BC. So BC is 2x minus 5. But instead of x, we're going to put 17. So we have 34 minus 5, and that gives us a length of 29. Number 3, a square with a diagonal of 6 square root of 2 and a rectangle have equal numeric areas. The ratio of the width to the length of the rectangle is 1 to 4. So what is the perimeter of the rectangle? So here we have a square with diagonals of 6 square root of 2. That's more squarish. So the diagonal is 6 square root of 2. Now a square can be broken down into two 45, 45, 90 triangles, which means the side lengths of this are 6. And that means the area is 36. Now the rectangle, we have width and length in a proportion of 1 to 4, but this also has an area of 36. Straighten that up. So what we can say is this is x and this is 4x. So 4x times x equals 36. So 4x squared equals 36. When we divide by 4, x squared is 9. So x has to equal 3. Now, 3 is not our answer, though. We want the perimeter of the rectangle. So we've got 4x, we've got x. So That means when I substitute 3 in for x, we've got 3 and 3, 12 and 12. So 3 and 12 make 15. If I double that, we get a perimeter of 30. Number 4. In this diagram, 1 is complementary to 6, and 8 is equal to 22. So we want the degree measure of 4. So this we have 22, so 6 is 22. Now 1 and 6, they are complementary. So that means these two will add up to 90. So if I take 90 and subtract 22, we get 68 is equal to angle 1. Now we want angle 4. Now these two angles, 1 and 4, they are supplementary. So angle 4, so the measure of angle 4 is going to be 180 minus 68. And that gives us 112 degrees. Number 5. 4 interior angles of a convex pentagon have these measurements: 40, 75, 118, and 142. What's the degree measure of the fifth? So this is, let's see, this requires the angle sum formula. And that is, we take 180 degrees times the number of sides minus 2. So in a triangle, there's 180. In a quadrilateral, there's 360. But what we have is we have a pentagon. So that means we have 5 sides. So that means we're multiplying 180 by 3. So that means our total is 540. So what we have to do is we have to take these 4 and subtract them away to get what remains. And the quick way to do this, we'll give it to our calculator. And when we do that, we are left with 165 degrees. That's the last angle remaining. Number 6. The shaded portion of the figure is made up of 5 congruent rectangles. E and F are congruent squares. In each shaded rectangle, the length of the base is 2 times the length of the altitude. The outer perimeter of the entire figure is 56. So we want to determine the area of one shaded rectangle. So think about it this way: x, x, and x, 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 x. So you got x and x here, x and x here. And so our perimeter is 3x plus 4x plus 3x plus 4x, which is equal to 17x, which is equal to 56. Whoops, not 17. My fault. That is 14. So x is equal to 4. So we want the area of one of these shaded rectangles. So we have 2x and x. So the area is 2 times 4 times 4. And that gives us 32. Number 7, determine the total numeric area of the regions that are interior to a triangle with sides 3, 4, 5, but exterior to the circle inscribed within this triangle. So we're talking about a 3, 4, 5 right triangle. And then inside of that, we have a circle that is inscribed. All right, not exactly a circle, but it'll do the job. Now, the key question is, what is the radius? Okay. Now, the way we figure this out is we realize that the radius meets the sides of the right triangle at right angles. So now here, this is a quadrilateral, and I've got a right angle here, two more right angles, which means this is also a right angle. So that means I know this length from here to here. This is R, and I know this length here. This is also R. So by consequence, I know this length here, this is 4 minus R. And this length here is 3 minus R. Okay. Now, the final step is that these two shapes, if you notice, these two are congruent. They are the same length. Well, as it turns out, these two sides here are also congruent. And if you want to, if I drew this line right through here, it would break this into two triangles, and you could probably quite easily show that by congruency that we have two congruent triangles here. Now, because these two triangles are congruent, that means this side right here is also equal to 3 minus R, and this piece right here is equal to 4 minus R. But wait a minute, these two add up to 5. And that's our key right there. 3 minus R plus 4 minus R equals 5. So put together, we have 7 minus 2R equals 5. So negative 2R equals negative 2, so R equals 1. So in this, a 3, 4, 5 right triangle, the inscribed circle has a radius of 1. Now, we're not done. We want the area that's outside the circle, but inside the triangle. So we need to find the area of the triangle, so that's 1/2 the base times the height, and then we have to subtract away the area of the circle. So that's pi times 1 squared. So we have 6 minus pi. So there is our area. Number 8, quadrilateral PARL is a parallelogram with numeric areas of 120, and GL and GR are equal. So we want the numeric area of this. Let me tell you, I took a long time trying to figure this one out. I even saw some solutions that I wasn't too happy with. So I came up with a different solution that I think it works better for me. You may not like it, but this is the one that I prefer. That's a little more geometric and a little less algebraic than the one that I found. Okay, so we know that this area is 120. Now the way you find an area is you take the base times the height. So I'm going to call this x, I'm going to call this x. Now, that means this right here, the height, is 120 over 2x. Or I can simplify it and just say 60 over x. Now I'm going to stick a pin in that and I'm going to come back to it. GL and GR break this equally. Now this is a parallelogram. They told us that. So these sides are parallel and these sides are parallel. Now what if I drew a line right here that was parallel? Well, it cut this in half, which means it cuts this in half right here. So these two sides are also equal. So I've essentially cut this thing in half. Okay. Now, what I've also done is I've also cut this piece in half. This is the midpoint. Now I'm going to do the same thing going this way. All right, let's move this up slightly. There we go. Okay, so now what I've done is passing through this midpoint, now I've cut it in half this way. So this right here is 30 over x. Now what we want is we want the area of this triangle right here. But if you notice, this purple line is parallel to the top and the bottom base. So that means these two angles are equal, and these two angles are equal. And these two angles are vertical. So that means these two triangles are similar. They are not, however, they are not exactly they're not congruent. All right. Now, this right here is the midpoint of this line right here, which means if this length is x, that means this length is x over 2. So what we have now is we've got a proportion for these two triangles for all their dimensions. If this is a certain amount, this is half that. So h1 over h2 equals 1/2. All right, now we know that their combined heights is 30 over x. So h1 plus h2 equals 30 over x. But h2 is just twice as big as h1. So I can write as h1 plus 2h1 equals 30 over x. All right. Let's move that over there. So we have 3h1 equals 30 over x. So we divide by 3, h1 equals 10 over x. So then h2, the height of the second triangle, that's the triangle we want, is 20 over x. That is this right here. So now our area is 1/2 the base, which is x, times the height, 20 over x. And that gives us 10. The solution that I found had you turn it into a rectangle and then had you find equations. It works, but I wanted to keep it as a parallelogram. So it might look a little different than some other solutions for this that you may have seen. So hope that makes sense. If you have any questions about this one, make sure you put this one in the comments because this one took me a while to work through. All right, number 9. Right triangle ABC has a hypotenuse of AB and a leg of AC. So I've got a right angle, but they don't tell us, except they tell us that AB is the hypotenuse. And AC is 7.5. Now, key thing to note. A leg is half of the hypotenuse. Whenever you see that, you should instantly think this is a 30, 60, 90 right triangle, because only a 30, 60, 90 triangle has one leg as half of the hypotenuse, or the hypotenuse twice as big as the leg. So that means the measure of angle BAC is equal to 60 degrees. Okay, number 10. The supplement of a certain angle is 30 degrees less than 4 times the measure of the complement of this angle. So this problem is just deliberately meant to just turn you all around. So let me just break it into pieces. The supplement of a certain angle. I don't know what that certain angle is, so I'm going to call it x. Now the supplement means they add up to 180. So that means we're talking 180 minus x. Is, that just means equals anytime you see that. 30 less than. Okay, so that means we're subtracting something and then minus 30. 4 times, all right, so we're multiplying 4 times something. All right. The measure of the complement of this angle. Okay, so this is the supplement. The complement means they add up to 90. So 90 minus x. Okay, so now we've got an equation, so now we can solve this. So I'm going to multiply 4 into this. So we have 360 minus 4x minus 30. So the 30 and the minus 30 we can put together. Okay, so now we add 4x, so 180 plus 3x equals 330. We subtract 180. All right, let's check our numbers. Minus 180 is 150. So x, when we divide by 3, is 50. So that's the angle. Okay, so now that's not the answer though. We still have a little more to go. We want the degree measure of the supplement of the complement. So now we're going to start. So the angle is 50. The complement is 40 because these two add up to 90. Then we want the supplement of that. All right. 50. Okay. So now I can forget this angle part up here. I can just ignore that and just say, all right, I want the supplement of that. So if I take 180 minus 40, we get 140 degrees. So definitely one where you have to take it slow and take it piece by piece. Number 11, the lengths of the diagonals of a rhombus are in a ratio of 2 to 1. Now in a rhombus, the diagonals, they are perpendicular and they bisect each other. Now the area of the rhombus is 24. Now one way I like to think about this, there is a formula for the area of a rhombus, and that is 1/2 times each of the two diagonal lengths. What I prefer to do is I prefer to focus on just one of these four triangles inside. And so if the area of the whole rhombus is 24, that means the area of one of these triangles is 6. Now, because these rhombus diagonals are congruent and they're bisected, these are also in a ratio of 2 to 1. So 1/2 times x times 2x equals 6. So x squared equals 6. So x equals square root of 6. So we want the sum of the lengths of the two diagonals. So that means x equals square root of 6, and this is 2 square root of 6. So you have 2 square root of 6, and then square root of 6. So I have square root of 6, square root of 6, 2 square root of 6, 2 square root of 6. And they're all like terms, so I can add them all together, and we get 6 square root of 6. All right. Number 12. Let a, b, c, k, and w be positive integers, such that a squared plus b squared equals c squared, and c squared plus k squared equals w squared. This is all Pythagorean triples. That's what we want. And we want these numbers to be as small as possible. So you should definitely know 3, 4, 5, which can be a squared plus b squared equals c squared. So a equals 3, b equals 4, c equals 5. So we want a Pythagorean triple that starts with 5, and that's going to be 12 and 13. 5 squared plus 12 squared equals 13 squared. So that means k is 12 and w is 13. So 12 plus 13 is 25. Number 13. Parallelogram ABCD has vertices at these 4 points. Now, since I've got grid paper here in the background, I'm going to use that to help draw this picture out. So the first point is letter A at the origin, and letter B, so 1, 2, 3, 4, 5, 6, comma 1. So letter B is going to be right there. Letter C is going to be at 8, 2, 3, 4. C is right there, and point D is at 3 right there. So there is our parallelogram. The question is, how do we find this area? Well, what you do is think about this as a part of a rectangle. And so this is 8 and 4. So I start with an area of 32, but then I have to start chipping away the little rectangles that I don't want to count. So this right here has an area of 2. This right here, 1, 2, 3, 4, 5, 6. So this has an area of 3. This also has an area of 3. Height of 3, base of 2 times a half. And then over here on the other side, it's going to be similar, 2, 3, and 3. So minus 3, minus 2, minus 3 for one side, minus 3, minus 2, minus 3 for the other side. So when I subtract all that away, all of this on the inside is 16. Number 14. So we have in triangle ABC, AB is 18, BC is 12, and B is 90 degrees. So we've got another right triangle here. So AC. So AB is 18, BC is 12. Not to scale, that's okay. Point P is on AB, such that AP squared minus BP squared is BC squared. We want the length of BP. So I'm going to call this x. So then this is 18 minus x. So what I'm going to do is I'm going to write out an equation. AP has a length of x. BP has a length of 18 minus x squared equals 12 squared. Now I need to expand this out. All right, so 18 squared is 324 minus 18x minus 18x plus x squared equals 144. Now, got to distribute the negative into everything. So x squared minus 324 plus 18x plus 18x minus x squared equals 144. Now notice the x squareds, they cancel out. Well, that's nice. The 18x's, I'll combine those. So we take 144, we're going to add 324. So 36x equals 468. And then when we divide by 36, we get x equal 13. But we're not done, because we want the length of BP, and BP equals 18 minus x. And that gives us a value of 5. Number 15, points 0, 0, 5, 3, and 8, 0 are points on a circle. So the numeric area of this circle is k pi. So what is the value of k? All right, so we have 0, 0. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now, important thing here is that these 2 points form a chord. And with all chords, they are the perpendicular bisector of the radius. So it's going to look kind of something like that, more or less. So I know for a fact that the center point is somewhere along x equals 4. All right. But I need to figure out what the radius is. So what I need to do is I need to use the equation for a circle. And that's this. X minus h squared plus y minus k squared equals r squared. Now what do I now know? I know that h has to equal 4, because that's the x value of the center. So x minus 4 squared plus y minus k squared equals r squared. Well, that doesn't seem to help the situation a whole lot, does it? Because all we know is this. Well, what I'm going to do is I'm going to plug in 0, 0. 0 in for x and 0 in for y. So when we do, we have negative 4 squared plus negative k squared equals r squared. So what does that leave us with? That leaves us with 16 squared plus, 16, plus k squared equals r squared. Did that help? Well, maybe, maybe not. Now what I'm going to do is I'm going to plug in 5, 3. So now I'm going to plug in 5 minus 4 squared plus 3 minus k squared equals r squared. So on the left, this becomes 1 plus 9 minus 6k plus k squared equals r squared. So this becomes 10 minus 6k minus 6k plus k squared equals r squared. Now, notice that this right here, let's highlight these, this equation and this equation I got by plugging in different points, but notice that they're equal to r squared. Since they're equal to r squared, I can set them equal to each other. So 16 plus k squared equals 10 minus 6k plus k squared. So we subtract k squared. So you have 16 equals 10 minus 6k. So we're going to subtract 10. So 6 equals negative 6k. So that means k equals negative 1. All right, now we've got our value for k. Now all we have to do is figure out what is the value for r. So x minus 4 squared plus y minus negative 1 squared equals r squared. So now I can pick any of these points to plug in. So here if I plug in 8, 0, that's going to give me r squared. So 8 minus 4 squared is 16. 0 plus 1 squared is 1. So we get 17. Now we want the area of the circle, and the area of any circle is pi r squared. Well, r squared is 17. So that is our answer. It's 17. Number 16. A certain triangle's base is increased 10%, and its height to that base is decreased by 10%. Determine the percent of change in the triangle's numeric area. Express your answer as an ordered pair indicating the percent change in the direction of change. Increase, no change, decrease. So they say if there's a 100% increase, it would be 100 comma increase. So anytime there's a percent change, what I like to do is I like to make the problem easy on myself and say that the base and the height were both 100. So that means that my area is 10,000. Now that makes percent change all that much easier, because if the base is increased by 10%, that means the new base is 110. And the height is decreased by 10%, so the height is 90. So now, whoops, forgot one thing up here. Yep, okay, forgot to divide by 2. So here, 1/2 times 90 times 110. And we get 4950. So this is a decrease. And so what we have to do is we have to figure out what is the percent change. So 4950 minus 5,000. And then when we divide that by 5,000, we get negative 0.1. So that is a 1% decrease. Now, if you didn't want to do it that way, the other way you could think about it is to take the area formula, 1/2. Now, a 10% increase would be 1.1 times b. And a 10% decrease of the base would be 0.9 times h. Now, when you multiplied 1.1 times 0.9 and then divided by 2, times 0.99 pH. There we go. You'll see that we have 0.99, which is 1% less than 100. Now, I can ignore the 1/2 because the 1/2 was there in the original 1/2 base times height. So we're looking to see how much this part right here changed. And so by growing the base by 10% and shrinking the height by 10%, we get this extra 0.99, and that is our 1% decrease. So that is what the answer for number 16 should have looked like. Number 17. In this figure, AX, BY, and CZ are all parallel. So AX is equal to 4, CZ is equal to 5. So we want to determine BY. I'm going to break this into two separate figures so that we can see what's going on. So we have A, X, Y, B, C. And then A, Y, B, C, Z. So CZ is 5. AX is 4. Now what we want to figure out is this length. I'm going to call it X. Now in order to make this problem work, I need to introduce some other values. So I'm going to call this A and B. I'm going to call this A and B. Now what we have is, because they are all parallel, we have a bunch of congruent angles. So that means we have similar triangles. So to set up my proportion, on the right, it's going to be B over X equals A plus B over 4. And on the right, I'm going to have A over X equals A plus B over 5. Now, with 3 constants floating around, it seems rather difficult in order to solve. So what I'm going to do is I'm going to solve each of these for A plus B, because that's the one thing that these two have in common. Now, we do have X, but I don't want to solve for that. I don't want to get rid of it. I want to keep X where it is. If I cancel it, I'm kind of out of luck, and I'm going to have to start over. So on this side, if I multiply the 4, I get 4B over X equals A plus B. On the right, if I multiply the 5, I get 5A over X, which is equal to A plus B. Now, since they're equal to each other. So we have 4B over X equals 5A over X. Now, if I cancel the X's, we just have 4B equals 5A. What I've got now is I've got a conversion, meaning I can convert one of these letters into another. So I could say either that B is equal to 5A over 4, or I could go this way and say A is equal to 4B over 5. So what I'm going to do is I'm going to substitute this up here into this, but I'm going to change my proportion. I'm going to rewrite it in a slightly different way that's going to make it a little nicer. So I'm going to write it like this. I'm going to write it as B over a plus b equal to x over 4. So now, when I make this substitution, I get 5a over 4 all over a plus 5a over 4 is equal to x over 4. Okay. Now, I can factor an x out of the bottom and out of the top. So I can just make that go away. 5/4 over 1 plus 5/4. So 5 over 4 divided by 1 plus 5 over 4. And so we get 5 over 9 is equal to x over 4. So when I multiply the 4 over, I get 20 over 9 equals x. So this is how you solve this. This is definitely a very messy, very involved problem. And if you wanted to solve going the other way and substituting in over here, you definitely would have found the same answer. Number 18. Jake's delivery route goes from 3.9 to 1.6. Maria's delivery route goes from 1.9 to 3.6. They meet for lunch at the intersection of theirs two routes. So what is the intersection? So let's use my grid lines that I have here. So I have 1, 2, 3, 1, 2, 3, 4, 5, 6, 9, right there. There's 3, 9. We go to 1, 6. So 1, 2, 3, 4, 5, 6. And then, all right, so that's this one, and then this one, from A to C, and then from B, go from 1.9 to D. So the intersection is at the halfway point, and if you notice, the x values and the y values are the same, they're just flip-flopped. So we're looking for the midpoint between 3 and 1, so that's 2. The midpoint between 9 and 6, which is 7.5, which is 15 halves. And so this is the ordered pair for our midpoint. Number 19. Prism M has a length, width, and height of 16, 3, and 4, respectively. Rectangular prism M has length, width, and height of 8, 6, and 6. Determine the ratio of the lesser volume to the greater volume. All right. So the volume of M is 16 times 3 times 4. So that is 192. The volume of N is 8 times 6 times 6. So that is 288. So now we want the ratio. So that's 192 over 288. So 192 by 288. And if we simplify that fraction, we get 2/3. And the last question. Quadrilateral ABCD is a trapezoid with AD and BC are parallel. And BC and AB and BC are perpendicular. Now that means if they're parallel, that means these are also perpendicular. Sides AB is 5 and BC is 10, with vertices of B at 1, 2 and D is 6, 7. Now, one thing to note is that from here to here, we add 5. Notice that. But here to here is also 5, which means we also go over 5. So essentially what we have is we have a square, and we have an isosceles right triangle here. Now, we want the area of this trapezoid. So I can just break this apart and say that this has an area of 25, and this has an area that is half of that, 25 over 2. Now, we want it as a common or an improper fraction. So when we add these together, we get 75 over 2. All right. If you have any questions or any alternate solutions, put them in the comments below. Thanks for watching.